uric acid is a kind of a key player in how fructose works. And what's interesting, and I think many of you know this, is that humans have high uric acid levels compared to most mammals, and it's due to a mutation that occurred in an enzyme called uricase, millions of years ago. And in fact, it's using molecular evolution, you can actually identify what the mutations were and when they occurred. And they occurred around 12 to 15 million years ago. And they involved not just the great apes, which involved, orangutans, chimps, gorillas, and eventually also humans fall in this group, but also lesser apes. And there were parallel mutations suggesting that there was some survival advantage to having a higher uric acid. But why would that be? I mean, uric acid causes gout, forms crystals. I mean, that's not a survival advantage. You'd have trouble escaping a predator if you had gout. In 1920, in the United States, the mean uric acid level was 3.5. 5 was considered markedly elevated back then. Then by 1960, 5.5 was the mean, and 6.5 was viewed as really high. And today, it's not uncommon to have uric acids of 6. And so now it's 7, or some places say 8 is high. So we keep changing our, what's high, because every decade it's going up. And it's going up because of the sugar and the alcohol and all the foods we're eating that are driving the uric acid up. So now, maybe 20% of the population have hyperuricemia, especially in men. And when you look at the relationship of uric acid to obesity, it is pretty dramatic. I never thought it was this dramatic, but look at this. This is from the NHANES. There's a stepwise increase in uric acid with obesity. There's a stepwise increase with diabetes. There's a stepwise increase with hypertension. And there's even more of an asymptotic rise with kidney disease. It is there. There is a relationship that cannot be denied, but that doesn't mean causality. But our work suggested that it could. And when we lowered uric acid, we could block some of these effects. So we've gone on to try to understand how does it cause weight gain. And we found that fructose does it through leptin resistance. And the way you prove leptin resistance is you have to inject the animal with leptin. And normally when you inject an animal with leptin, they will reduce their food intake for about 12 hours. And you can measure that over, like a 24-hour. And when you give them fructose, they become completely resistant to leptin. Leptin doesn't work at all. And as you probably know, most people with obesity have been found to have leptin resistance. And we found that was what was responsible for weight gain. And, because they eat more, and that does it. And if you block the ability for them to eat more, they won't gain weight. So weight gain is really a calorie-based problem. And fat intake, when you become leptin resistant, you also start liking fat more, as you probably are aware. And when you eat more fat, that really accelerates weight gain because you're leptin resistant. On the other hand, we found that the mitochondrial effects of fructose was what drove all these metabolic diseases. In fact, we could put animals on caloric restriction and reduce their calories a lot, but if they ate sugar, they would become diabetic, hypertensive, fatty liver, etc. Okay, well, it's great to say fructose is important, probably is, but what about cultures that don't eat a lot of sugar? I mean, it's not that they don't get obesity. What about the emperor penguin who gets fat and there's no fruit down in Antarctica? So there's got to be other mechanisms. Well, the big surprise was that fructose can be made from glucose. And we've known this, but we never knew how important it was. But there's this pathway called the polyol pathway where glucose is converted to fructose. And this is the only way fructose is made in the body. And what drives it? Guess what drives it? High carb diet, high glycemic carbs, diabetes. You can take a diabetic person who has bad glucose control. You don't have to feed them any fructose. They all have high fructose levels, blood levels, and urine levels of fructose. It's well published. And likewise, if you give animals carbs or even humans carbs, you can measure a rise in fructose production. both production and levels with that. So it turns out that you can make fructose from carbs. And that's really important because there's a lot of these carbs called high glycemic carbs, starchy foods like rice, potatoes, cereal, bread. And if you eat those, your glucose levels go up. And as your glucose levels go up, you can convert as much as 30% of that glucose to fructose. So it's not the 3% in a normal, under normal glycemic conditions. When it goes up, the amount of fructose produced goes way up. And we could show that in animals by giving them glucose, showing that their fructose levels go up, they become fat, they become insulin resistant. And if we block that fructokinase enzyme, that KHK enzyme, we could block obesity. Now, there was some obesity that was being driven by the insulin. And we were able to show that there's really two mechanisms. There's an insulin-dependent mechanism, and there's a fructose-dependent mechanism. And fructose makes up about half of the effects, and glucose insulin makes up about half the effects.